Welcome back to your video about factors and prime factorization. Our goal for this video is to determine the prime factorization of a number. Before we get started, let's review what prime and composite numbers are. So a prime number is a whole number above 1. I want to stress that, that's why it's bolded. That cannot be made by multiplying other whole numbers. A composite number are those numbers that have more than 2 factors. So we're going to look at these 4 examples and determine if they're prime or composite. So an example of a prime number, down here, here's a little fact. The smallest known prime number is 2, which is the only even prime number as well. So it's a little fact for you, but the reason that 2 is the smallest prime number is because if you list the multiplication facts that give you 2, it's 2 times 1. And that's it. There's nothing else you can multiply to get the answer to. Again, a prime number only has 2 factors. A composite number has more than 2. So the number 4 is composite because you can do 4 times 1 and you can do 2 times 2. The reason that 1 is not prime is because it only has 1 factor, 1 times 1. So again, a prime number is above 1. 2 is the smallest prime number, and then it can go up from there. So if we look at 65, okay, I know that 65 can be 1 times 65, but it can also, it's a multiple of 5. And you can kind of figure that out if you want, but you can also just know that because it ends in a 5, it's going to be in the 5 family. It's 5 times 13. And there may be more factors than that. I don't think there are, but the only thing that matters is it has more than 2 factors. So 65, I'm going to put a C. It is composite. 8, you can do 1 times 8, and we can do 2 times 4. So 8 is composite. 41, the only 2 factors of 41 is 1 and 41. You cannot get 41 multiplying any other whole numbers. So 41 is prime. And 53, same thing. The only factors of 53 are 1 and 53. So 53 is also prime. So let's talk about what the prime factorization is. So we know what prime numbers are. Again, they're numbers that only have 2 factors. Okay. The prime factorization of a number shows the number written as the product of its prime factors only. For example, the numbers 5 and 6 are factors of 30. So I'm going to show you how to do a factor tree. So if I'm thinking of 30, you can do this in any pairs you want, but for this example, I know that 5 times 6 is 30. This means multiplication, by the way. Times, this is 30 being factored, but it's not the prime factorization because you can continue to factor your 6. You can't factor out 5 anymore. You could do 1 and 5, okay? But once you get to that prime number, you can stop. 6, I can factor into 2 times 3, and both of these are prime, so nothing else can be factored. Therefore, the prime factorization of 30, you would write 2 times 3 times 5. And I like to put my numbers in order from smallest to largest. Okay? So there are 2 methods. I just showed you how to use a factor tree. Okay? You can also use what's called either stepped division or repeated division. And it's where you're dividing the number you're starting with by prime numbers. And so 36 divided by 2 is 18, that goes here, and you keep dividing out until you end up with a prime number. And those numbers on the outside are your prime factorization. The way that you know your prime factorization with a factor tree is remember that you stop once everything is a prime number, and those are your numbers for your prime factorization. So either way, you end up with the same answer. Let's go ahead and try practice problem 1. Find the prime factorization of 90. Show your work in both ways. So let's start with our factor tree. And in my brain, I think of 9 times 10 first. So that's what I'm going to start with. But these can both be factored. I can continue to factor 3 times 3. And I'm done here because 3 is a prime number. And then 10 is 5 times 2, and both of these are prime. So I'm done. The prime factorization would be 2 times 3 times 3 times 5. Okay? So that's how you do it with the factor tree. Step division. I'm going to put 90 here, and I'm going to draw a little step. And remember that with this, you have to divide out by prime numbers. So I'm going to divide by a 2, which is 45. Then I know that I can divide by a 5, which is 9. I can divide that by a 3, and that is 3. Again, I end up with that same answer. I'm just going to put my numbers in order of smallest to largest. And I am done. For this practice problem, I challenge you to pause the video and give it a try, and I'm going to have you choose whichever method you prefer. So I myself kind of like a factor tree because I can think of whatever facts my brain likes the most. With the stepped division, you have to divide out by a prime number, but you're going to get the answer either way. When I think of 28, I think of 4 times 7. You might think of 2 times 14, but we'll end up at the same answer. 7 is prime, I'm done. 4, however, is 4 times 1, but also 2 times 2. So I'm done there because both the 2's are prime numbers. So my answer is 2 times 2 times 7. So before you leave, make sure you feel really good about determining the prime factorization of a number. And if you need to rewatch this, definitely go ahead and do that. And thanks for watching.